You're listening to The Weather Junkies.
Oh boy. A large wedge tornado coming up into Tuscaloosa. A winter storm warning is in effect for our area.
So we can expect at least another 2 to 4 inches overnight. Then that snow.
The National Weather Service in Huntsville has issued a tornado warning for northwestern Massachusetts.
14 to 22 inches of snow!
Good Thursday evening. Thank you for joining us here live on The Weather Junkies. It's the first day of fall, and I'm Tyler Jankowski, joining the show from Connecticut with Dakota Smith in Colorado. Dakota?
Hey everyone, and hey Tyler. Thanks for joining us again tonight. Last week I declared that it was the beginning of fall in Colorado because it's getting pretty chilly at night. A few of the leaves are starting to turn, and that has kind of continued. Went through a little bit of a hot spell over the weekend, got into the 80s a bunch of times. But it's back to cold again. We have a cold front moving in, and it's just wonderful. I don't have AC in my house, so I love it when it cools down. You can put the fan in the window, and it feels nice. How's the weather over in Bristol?
It's been warm the last couple of days, but we are expecting the first real taste of fall this weekend when temperatures will only reach the middle 60s on Sunday. So I don't know, maybe the last bit of summer is going away. Hopefully there's another bout of warmth later on, maybe October, but it's a little bit of a wake-up call because it's been very warm so far. So yeah, back to average.
Are you trying to hang on to that warmth?
Well, I kind of want to. It's kind of like a unrealistic goal, but I was thinking of maybe going to the beach one more time or trying to take the boat out once, just because it never happened the way I wanted it to at the end of summer. I don't know. I just have that in the back of my mind. Gotcha.
Well, tonight we're joined by a good friend of ours, Matt Mahalik. He got his bachelor's in meteorology from Penn State and his master's from Texas Tech in atmospheric science. And right now he's at the Cooperative Institute for Mesoscale Meteorological Studies. He's been there since 2015, July 2015. And he's part of the Severe Weather Warning Applications and Technology Transfer Group. My gosh, there are a lot of acronyms in meteorology. But he does a lot of work with tornado rotation tracks. And he's even helping to develop a mesoscale and tornado detection algorithm, which we'll get into a lot of detail in a little bit. Matt, thanks for joining us tonight.
Hey guys, it's really good to be with you guys. And honestly, this is actually my first time doing a live podcast like this. So my goal is just to not say anything stupid enough that I have to apologize tomorrow.
No, the stupid stuff gets clicks. So say this. Yeah. So you're in Oklahoma. I assume you're in Norman. How's the weather down there?
Yeah, it's. I was listening to your intros, and I'm kind of jealous actually because it's been pretty brutal here the past few days. It's actually been up in the 90s with some pretty decent humidity too. A couple days ago, I just took a glance and I saw in the Oklahoma Mesonet the Norman station was reporting a heat index of 105 degrees. So. We're still hanging out around 90 degrees most afternoons, fairly humid, but we've got a change coming, and I'm really looking forward to getting some cooler air in.
Gotcha. Well, we'll talk with you and a lot of your research in a minute, and feel free to chime in as we go into our Trending in the Twitterverse segment here. Our first tweet is from Philip Klotzbach. He was actually a guest on the show about a month ago. You can follow him at Phil Klotzbach, and his tweet says, Atlantic ACE showing a statistically significant decrease during the time that Brangelina were together. If you don't know what ACE is, it's accumulated cyclone energy, and basically he's saying that there's been less of that since Brad and Angelina were together, and now unfortunately they're divorced. Thought it was a funny chart that he put out here.
Got 45 retweets and 82 likes, so I suppose it was successful. It says it was from Manchester, New Hampshire. I wonder what he's doing here in New England.
Oh wow, I didn't even notice that. I know he lives in California and he is in Colorado every now and then, but I love when people combine weather and humor. It's probably one of my favorite things. There's a lot of it on Twitter these days. Our next tweet comes from, I actually don't know what the, let's see, I'll read it.
AOML.
Yeah, it's kind of a weird name here, but they're the Hurricane Research Division, part of the Atlantic Oceanographic and Meteorological Laboratory, part of NOAA. And their tweet says, digital copies of Ted Fujita and Roger Wakimoto's hurricane landfall analysis now available. And if you don't know who Ted Fujita and Roger Wakimoto are, they're some of the two of the premier researchers when it comes to mesoscale meteorology. And it was actually, you've heard of the Fujita and the enhanced Fujita scale, named after Ted. And yeah, this is just awesome. I took a look at the Hurricane Andrew one, and it was just weather porn. Essentially, it was pretty awesome.
Sounds like an NWS Podunk run account. But anyways, we'll move on to our next tweet. And this one I actually did not see in real time, but it's a fabulous tweet. It's from Matt Lanza. And he says, MLB seems to have a solid weather plan in place. I mean, seriously, it's going to take a fatality, isn't it? And he's quote tweeting someone that says, oh, geez, it's hailing at Coors Field. People are screaming and running for cover. Ugh.
I just would like to jump in for a second and would like to fully endorse Matt Lanza as becoming the official meteorologist of Major League Baseball. I know that's been a mission of his for a while now. So he's doing good work, hopefully bringing this to everybody's attention.
That would be great. I agree with that endorsement. I'll second that endorsement because it's just ridiculous some of the things that happens at baseball games. It happens in the summer during the, when there's a lot of storm activity, and they always seem to get themselves in sticky situations. And I think Matt's right. I think unfortunately it's probably going to take a fatality and then lawsuits to get them to actually do something about it.
Well, I will say that I'm reading the follow-ups here. You said Dakota, you talked to the VP of Park Operations?
Yeah, I did actually. I didn't think we were going to get to that, but yeah, I did a podcast on severe weather safety at Red Rocks, which is a pretty famous concert venue out here in Colorado. It's in Morrison, Colorado, and it's terrible. Their policy's terrible. They get good information. They use a private company, and they have good information, but they have a terrible plan to where to put people. And so subsequently, I talked to the Coors Field VP of operations. I think it was event operations or something like that. And they actually use the same private company, but they have a pretty good plan because they have a concourse and people can actually get to a safe spot. I don't think they take it as seriously as they should because they don't ever force people in the lower concourse to move. Just the people in the upper concourse, which seems kind of silly to me, but
it's interesting that Matt says it's the umpire's discretion on the final call, because I have a lot of experience doing this at the televised Little League regionals. And obviously, if an umpire on the field says that there's lightning, you can't dispute him publicly and say no. But at the same time, we have obviously a robust meteorology team behind the operation that me and someone else actually had an article written about the whole operation. But, especially at night, you can see lightning 50 miles away. So if an umpire were to make a decision based on that, it would be way wrong. You can see lightning 70 miles away when it's no threat. If you have like a discrete storm cell, as long as you're confident it's coming from that storm cell. So you absolutely need a meteorologist. So this is just another chapter in the long-running Major League Baseball embarrassment book.
Hopefully they look at it, but like Matt said, I think it's going to take something bad to happen. And on to our next tweet from Mike Betts, meteorologist at the Weather Channel. You can follow him at Mike Betts. And this is something we talk about a lot, and I don't want to spend much time on it, but it pissed me off so much. I was like shaking with fury. He sent out a tweet, said, "Here's a look at the Farmer's Almanac Winter Outlook. The editor joins us live in the Weather Cave at 6:40 to talk 200 years of the Almanac. What is happening?" Why? It's the Weather Channel. Why is the Weather Channel sharing this and broadcasting this? And
That's a beautiful graphic.
yeah, I know.
Well, I didn't watch the interview, but I would assume he stated the truth.
Oh yeah, I need to watch the interview. I guess that would help, but
Penetrating cold. Wow.
Why?
Scary.
It's amazing how a lot of these outlooks, also from the Farmer's Almanac, they almost always seem to follow state lines really perfectly. Amazing how that works.
Yeah, I heard the weather also follows state lines too. So
yeah, state lines and county warning areas.
Well, NWS Podunk would agree.
Absolutely.
All right, let's move on to our last tweet here. Tyler, I'll let you take this one away.
Yeah, this is actually breaking right now. That's the beauty of a live show. I bring this up obviously because I work in media, but Facebook, the behemoth, has made a huge error. For 2 years, Facebook has overstated the length of time users spend watching videos. Apparently, in their metric, they only counted video views 3 seconds or more. In other words, if you watch for 1 or 2 seconds, they didn't count that view because it would have drastically lowered the average. So they've been counting these video views in a grossly erroneous manner, and these advertising firms are all up in arms that they've been shifting a lot of money to Facebook, when in reality, it's all a lie and it's not even accurate. And now Facebook is going to come up with another metric called average watch time, which will reflect views of any duration. There's a lot of advertising agencies in here, obviously spending millions of dollars, but it just makes me laugh that that Facebook is now admitting to a major mistake, and the average view time is much less.
Yeah.
When it seemed like gold and everything was going so well.
I saw a prominent YouTuber, Hank Green, rant about this. It was like a year ago maybe, or I don't know, 6 months ago or something. But he ranted about how he hated their algorithm because he knew that it over amplified their data, and that's exactly what is coming out now. So it's pretty bad news, I guess.
Well, the other good point brought up in the article is that there needs to be like a third-party group measuring what's going on and how many views there are. It's a problem when you have a company like Facebook think they can control everything and not release any data, only the data they want to. Anytime they're brought back to reality a little bit, I laugh. So this is a good story to see.
So that's actually a problem, I think, on a lot of different fronts. I can't attest personally because I actually haven't been on Facebook in a couple of years.
Good for you.
Yeah, thanks. But not only, first of all, it kind of rubs me the wrong way to hear science and scientific processes like this not being done the way they should be. But even beyond that, like Tyler said, a lot of companies depend on Facebook data, but also bringing this back to weather, you have organizations like the National Weather Service that absolutely spend a lot of time looking at Facebook data and develop a lot of their products based off of the data that they get. I just got back from the National Weather Association annual meeting just last week, and there was a really good presentation discussing the time during a video when the viewers actually just cut out. And a lot of times people stay for the really interesting and dramatic beginning, and then will cut off halfway through before they even get the important message at the end. So if even that data isn't necessarily as accurate as it needs to be, that's a problem with wide-ranging impacts.
Yeah, I totally agree, and thanks for bringing that back to weather. This is a weather show. Yeah, so I guess we'll see how that pans out in the future here, but definitely something to take and keep track of if you're a broadcast meteorologist. So that's it for trending in the Twitterverse. Let's get to my read of the week. It's a kind of a new segment. We'll see if it sticks. But I'm going to introduce something that I thought was interesting, whether it's research, a blog post that I read this week. So this week, it's the implications for U.S. national security of anticipated climate change, published by the National Intelligence Council. It's 5 pages. It's not too long. You can find it. We'll share it. Actually, it's 13 pages, but there are a bunch of blank pages in there. But you can find it on our Twitter, on our website, and essentially it goes through what the IPCC results are, Intergovernmental Panel on Climate Change, and what they mean for national security. It doesn't really get into the solutions, mainly just brings up the problems that we might face in the next 5 to 20 years. And I think it's hoping to encourage government, business, and academia to find solutions to some of these problems. It touched on increased risks to human health, heightened social and political tensions, and implications for investments and economic competitiveness. It went into depth about infrastructure on coastlines and how that's going to impact insurance and premiums. And there's a lot of interesting stuff. One tidbit that I'll share that I never thought of is there is contention over Russia's claim to 1.2 million square kilometers of Arctic shelf, which Moscow submitted to the UN in August 2015, and that could increase some of the tension between Denmark and Canada. And one other thing is there's opening waterways as some of the sea ice melts, and it encourages Western cruises to plan longer trips that go through the Northwest Passage. And I thought that was pretty interesting. They have to, I guess, caution them for doing that because there are a lot of variables there that could cause risk to some of their people on the boat. So that's my read of the week. Check it out. You can find it on our Twitter or on our website. So let's get into the main segment this week, and that's talking with Matt about his research on mesoscale cyclones, anything really severe weather. Matt, I'm curious. Let's start this off by getting how you got into weather and what kind of drove your passion.
So I'm one of those guys that I've always been interested and fascinated with the weather as long as I can remember. So I'm from Pennsylvania originally, and I lived for a while up on the shores of Lake Erie, there in Erie, PA, and it was a combination of just the incredible lake effect snow in the winter, and then the occasional really big thunderstorm moving through in the summer that got me just hooked, I think, right from the start. And I even have a yearbook from when I was in elementary school, from like 5th or 6th grade or something like that. And I had written in there what I wanted to be when I grow up. It was a meteorologist. So definitely as long as I can remember. Now, what I wanted to do with meteorology since then, that's kind of evolved as I've gone along. And some days I'm still not exactly sure what I want to do. At least now I think I like studying mesoscale weather, tornadoes, and severe thunderstorms. But there's nothing that's not completely fascinating about the atmosphere and how it works to me.
Gotcha. And so what's kind of your focus now at I don't know, what's the way to say, is it CMIS or what do they call it?
It's SIMS.
SIMS, okay.
Yeah, so we get confused a lot because there's a SIMS for mesoscale meteorology here in Oklahoma, and there's another SIMS with 2 S's and 1 M that's based out of Wisconsin.
Yeah, that's right.
So it's pretty confusing. We're SIMS with 2 M's. So we're a cooperative institute. So I work primarily with the University of Oklahoma. They're the ones that paid the sign off on the checks. But I also work for NOAA, National Severe Storms Lab, NSSL. So what I do there is kind of, it's actually really nice because as a cooperative institute, we have a little bit of freedom to kind of pick out some areas that we think there needs to be some research done in. There's some gaps in the knowledge. And so we, of course, have our own products, our own projects that are funded. And so those are the ones we take care of first. But then there's some other things that we can kind of work on the side and tie it all back together, which is really, really cool. My primary work is in coding up algorithms, so radar-based algorithms. I generally, most recently, I've been working on rotation detection algorithms and the calculation of azimuthal shear, which is just really a fancy way of finding out where there's inbound and outbound velocity, so spinning across a radar azimuth. So we're looking at different ways to take this azimuthal shear. We've now made it as accurate as possible. It involved some linear algebra and some calculus. I had to dig up some of my notes from Penn State undergrad, but derived some equations, got it working as well as possible, and now we're applying it to other products such as the rotation track product and also the new mesoscale or mesocyclone and tornado detection algorithms.
The rotation tracks display and product is fascinating to me. What's the biggest challenge that you've encountered in developing that?
Yeah, so the biggest problem with that is I think a lot of people don't really fully understand what goes into rotation tracks. And the rotation track product that we derive at NSSL and at SIMS are just taking our azimuthal shear product. So at any given radar scan, we'll have a bullseye of rotation wherever, hopefully, if it's working correctly. And then what we do is we actually will go through a few different radar tilts up vertically, and we'll go take so like, for example, between the ground and 2 kilometers off the ground. And in that vertical layer, we'll pick out what is the highest shear value that's happening in there. And then we'll accumulate that over time so you can see how that bullseye is moving. So a lot of the problems we've had with rotation tracks is there's a lot of data that goes into those. If you see a one-day rotation track product, you can have so many different storms that occur near one radar site, and then think of how many different radar scans that are scanning areas from the ground to 2 kilometers. How many of those radar scans happen over the course of a day? There's a lot of data. And so something we've dealt with in the past is the equations that have been used have been simplified. There have been a lot of terms dropped off because they weren't as important and it made it easier to calculate. Now that we have better computing capabilities, we're able to not throw out as much data and get the calculations as accurate as possible. So besides that, there are some other situations that throws the radar off, because this is why I always say we're still pretty far away from having things be completely automated, because the radar is easy to be fooled. We still need people to find some of these tricks. So one of the big problems that we run into is actually with squall lines, because if you ever look at a velocity image, you see when there's a squall line moving through an area, there's a lot of inbound velocity and a lot of outbound. So the radar sees a whole bunch of red and a whole bunch of green, if you're looking at a typical velocity image on radar scope. And that looks like, to the radar, a big area of shear, because it is horizontally. And so it tries to blow up that entire squall line as an area of circulation. So that's still a big problem that we're working through, although we do still also see some utility in that. It looks like when the shear zone is a little bit stronger, there's higher shear in that area. That could possibly, and this is still in the early stages, so I'm going to try not to be too irresponsible with the way I describe this, but we're looking at the possibility of applying that to estimating the little individual wind gusts, the strongest wind gusts inside squall lines. So that's just an idea that we've been playing with. But really, it comes down to the idea that radar algorithms, like rotation tracks, for example, they're all dependent on the quality of the data that goes into them. And I know you guys knew Fred Godomsky really well back at Penn State. He would always say, garbage in, garbage out. So if you have bad data going into an algorithm, you're going to have some bad data going out unless you put in a lot of work to overcome those deficiencies.
So for some of the less meteorologically inclined that are listening, these rotation tracks are hugely important because they tell us where some of the stronger storms are that are rotating, and it also tells us, or can tell us, where tornadoes might have gone through, and where they are if you're looking at live data. So Matt, when I'm looking at one of your products of the rotation tracks, right now I'm looking at the Central PA one you tweeted out. What exactly do you see when you look at this? What are you getting from this?
So what I see when I look at a rotation track product is, first of all, I make sure that I fully understand. Sometimes I even have to remind myself, because it's easy to say, oh wow, look at all these tornadoes and look at how long they were on the ground. But in reality, the radar doesn't see all the way to the ground. It never sees all the way to the ground. And so you have to remind yourself, technically, all you can get from that is there's rotation somewhere below 2 kilometers off the ground. And a lot of times that just means that there's some sort of rotation happening. It doesn't necessarily mean there's a tornado. However, when you get areas of very high shear values, so like in the rotation track products that I generate, when you see like reds and light blues, for example, at the high end of the color scale, there's a pretty decent chance that if there was a tornado occurring, that's when it was actually happening. So it's important to understand it's not necessarily a tornado track. It's just showing where rotation occurred. At the very least, it's a good way of tracking where the mesocyclone went. So if there's a supercell, it's a really good way to pick out a supercell's track and where the rotating updraft occurred. For situations where there are tornadoes, though, I think those are the most useful, because the rotation track is actually used, and it's requested specifically by NWS offices to figure out where the highest rotation occurred just based on radar. So with very little latency, very little delay, we can tell them, okay, here's probably where you want to look when you do your damage survey. And then probably even more importantly than that, we have emergency management officials and even the Red Cross sometimes will use our rotation track products to figure out where to send their resources to respond to a disaster. And I know that was a big thing with the recent Moore tornadoes in the past few years, and some of the other central Oklahoma tornadoes. Some of the first responders and then even some of the recovery missions, unfortunately, afterwards, use the rotation track product to understand where they were most likely to be needed.
So this rotation track product, did you say that it picks out the greatest rotation wherever that is, how high up it is? It's not at a constant level?
So the ones that we use operationally, and the ones that I'm generating and the ones that I'll be tweeting out, those are finding the highest rotation rates between the ground and 2 kilometers. So it's in the lowest area.
What do you do if you don't have radar coverage below 2 kilometers?
Well, I guess this is I'm glad you asked this, because this is a perfect time to plug a major product that we're working on called the Multi-Radar, Multi-Sensor Initiative, so MRMS. And so we actually operationally will blend in data from multiple radars. So say, for example, here in Oklahoma, if there's an area of significant rotation up near the Kansas border, it'll be more detectable on a northern Oklahoma radar or the Wichita radar than it would on the Oklahoma City radar. So operationally, what we actually do is we blend together, we merge the radar data from multiple different radar sources. And obviously, we still have issues in parts of the country where radar data is limited just in general. So like the Mountain West or parts of Missouri or North Carolina. I mean, I'm sure you guys have talked about poor 88D coverage before on this show, but so in those areas we're still limited, but at the very least we're able to see a couple hundred kilometers away from the radar and at least get a general idea of where rotation's occurring.
So that kind of leads me right into my question. How much have these products improved the warning time and location for tornadoes and severe thunderstorms?
So operationally, from a forecaster's perspective, it's still kind of in its infancy. There are active products such as the mesocyclone detection algorithm or the tornado detection algorithm. Those sorts of algorithms will produce something like a rotational velocity estimation. And I know even simpler than that, I know a lot of forecasters use this, a lot of broadcasters use this as well. It's just a simple estimation of gate-to-gate shear. So just looking at a velocity image and seeing, okay, here's some inbound and here's some outbound. And so we can estimate what the rotational velocity is from that. That's still the primary method, actually, operationally. Now that we've improved, and again, this is my main area of work over the past year or so since I started at Sims, revamping the coding and how all this is calculated, making sure it's as accurate as possible. Now that we've done some statistics on these and we've vetted their accuracy as much as we can, really, the next step going forward is to find ways to get this to the forecasters operationally and give them another tool, because sometimes it can be really tough, especially if you have a bunch of different circulations going on in a small area. It can be tough to pick out those circulations, especially if they're not very strong, on a velocity image. And so if now all of a sudden we have an azimuthal shear live real-time image that just blows up, it's just a bullseye wherever there's a strong area of circulation, that will hopefully save some time for the forecasters. Obviously, it'll take some time for forecasters to get accustomed to this. And I presented this work at the NWA conference last week, and some of the biggest feedback that I got and some of my colleagues got were that forecasters just aren't really used to looking at this yet, and they're not really sure, for example, what does an azimuthal shear of 0.008 inverse seconds actually mean. So it's going to take some training with forecasters and to get them comfortable with using a brand new data set like this. So fortunately, here at SIMS and NSSL in the National Weather Center, every spring we have something called the Hazardous Weather Test Bed, the HWT, and a bunch of forecasters from all across the country will come in and undergo training on things like this. So that's what we're doing going forward. So I guess that's the long-winded answer, is not much in real time right now for forecasters, but going forward, we think that there's a really good opportunity to get this working and hopefully cut down on forecaster time when toggling between products.
Do you do any work with tornado debris signatures?
Me personally, I don't work directly with the TDS, but I know there's a lot of work going on with other members of my research group that are working on that. We're focused, I'm more focused on kind of less of the forecasting aspect and more of the getting the real-time display working and as nice as possible. But I know there's a lot of work, like I said, going on with the TDS, and there are a lot of opportunities to use the TDS in new ways, I think, going forward too.
So when you think of the rotation tracks product going forward, would that be possibly something that's distributed as a radar product with each radar site? Either, I don't know, level 3. I don't fully understand the difference between level 2 and level 3, but would it be something that the end user could choose as one of the products to display?
Yeah, at some point, I think that's absolutely possible. It's so like I said, so the rotation tracks are generated in an entire CONUS sense, continental U.S., using the MRMS method, so combining different radars. But the azimuthal shear that goes into that actually is generated at each radar site individually. And so with some of the next upgrades that are going on, the newest releases of radar software at each individual site, we would expect, we hope at least, that this will be something that can be generated much more in a much more widespread sense. And especially after we test it and we get people more accustomed to seeing it, it's something that would be definitely more widespread going forward.
Yeah, I think this is. I hope to be able to use it in the future on radar scope. That would be really cool. You're next door to Weather Decisions Technology, so
Yeah.
hopefully that could happen in the future, because I would love to see that. So you have anything else that you're working on besides the mesoscale tracks?
Yeah. Sometimes I feel like a jack of all trades. I'm one of those guys that I just want to get my hands in everything that looks interesting to me. So one thing that's really interesting to me is some of the math that goes into calculating azimuthal or rotational shear. We can actually turn some of the equations around and calculate a different component of that. And it's actually not too difficult to derive an expression for divergent shear. So in addition to areas of rotation, what I'm working towards is getting a field that we can look at almost instantaneously with each radar scan of where convergence or divergence is occurring. And I think the biggest application for that over the next few years would be possibly applying that to downbursts. And I know the aviation community is still extremely interested in finding some way to be able to predict when strong vertical winds are going to come out of nowhere. So if there's some way that we can develop this divergence field and then maybe even work towards for example, a divergence, or I'm sorry, a downburst detector, or even predictor, I think that would be really exciting moving forward too, because mesoscale meteorology is about more than tornadoes. There is a lot of other products that need to be generated at some point going forward.
Yeah, it's sometimes you forget that it's more than tornadoes. The thing that fascinates me the most about mesoscale meteorology, and it's not really talked about, but it's the mesoscale meteorology that goes on during snowstorms. Just because you don't think about it when it's happening, but you get some of those mesoscale bands that set up, and that drops some of the biggest snowfall swaths in a storm.
Oh yeah, definitely. And if you ever need any reminder that heavy snow is often, if not usually, a mesoscale phenomenon, just wait for thunder snow.
Oh my gosh, I wish. That's on my bucket list. I've been in like a town where it was reported, and I never heard it. And
so, see, a funny story. So when I was a kid in Erie, we would get under an intense lake effect snow band several times a year, and there would be almost probably 2 or 3 times a year we would get some sort of thunder snow. At least that's how I remember it. And when I grew up and I moved away, and people started talking about, man, I wish I could see thunder snow one day, I would just be like, you mean that's not normal? That doesn't always happen? So I guess I was really lucky in that sense. It's a really, really cool phenomenon, especially now that I understand it and how rare it is.
I cannot be more jealous.
I know. I think the only person that might be even more jealous would be Jim Cantori.
Yeah, probably. He lives for that stuff. So you mentioned before the show that because you're a weather, I don't know, freak, and you love weather, blah blah blah.
A junkie, if you will.
A junkie, yeah, junkie, if you will. Wow, I can't believe I couldn't pick that word up. You go chasing every now and then because you're in Oklahoma. You like looking at clouds and fun weather stuff. How was your chasing season this year?
This year was, well, it depends on your perspective, I guess. I was unfortunately riding a streak at one point where I think it was either 5 or 6 tornadoes. The 5 or 6 tornadoes that I saw were all EF3 or 4 on the EF scale, and more than half of them ended up causing fatalities. And that's when at some point you take a step back and wonder why you're actually chasing. But all in all, I think we were pretty lucky this year. There were a lot of very nice photogenic tornadoes that occurred in wide open areas and didn't affect too many people. I'm thinking Dodge City in particular, from May 24th. I bring that up. That's always in my mind too, because I had an early meeting the next morning and I was thinking that's a little bit too far to drive. I'll get the next one. So, but no, all in all, for me personally, it was actually the most successful storm chasing season, despite getting stuck in softball size hail on 2 different occasions.
Wow.
But that sort of thing isn't ever going to deter me, because that to me is the most educational experience you can possibly get, is being out there and seeing the atmosphere move like that with your own eyes.
Yeah, I couldn't agree more. I wish the Metropolitan State University here in Denver has a class where they actually go out and chase for a significant portion of the time, and I guess they have the professor out there with them, and they find the storm, and they're looking at the radar, and they're looking at other stuff, and then they actually learn about it. And I wish that was a part of my meso class, but you know,
for sure,
we can't all live in the plains.
Yeah, no. One of my most memorable weather experiences at Penn State was seeing a rotating wall cloud crash into Mount Nittany one July.
Wow.
That doesn't happen very often. I saw that there was another really good supercell just really recently. I saw on Twitter from a bunch of my Penn State people, and so everybody that's back in State College, I can't say enough. If you get a chance to see something like that, you got to do whatever you can to see it, because that doesn't happen very often up there.
I think I only went chasing once when I was there, and it wasn't even chasing. We were just I think we just core punched this weak storm that had a little bit of hail, and now I'm on Colorado, and it's chase every other week or twice a week or something like that.
Yeah, it's a big difference out here. It's still weird to me that I could see an SPC outlook and be smack dab in the middle of like a 10% tornado chance and say, oh, I don't really think this is the best setup. I'm going to wait till next time. I couldn't imagine doing that 5 years ago.
Yeah. So there are some, I don't know, criticisms about that. I don't know if you want to get into that or not, but would some of the criticisms, there's been, unfortunately, a death in the chaser community, and that was in the Reno tornado. But do you think there should be some worry for chasers, or maybe some precaution about chasing?
Yeah, I don't know if worry is the right word for it. I would say respect. I think chasers need to be respectful of not just other chasers, because I've seen that's been a lot of the discussion over the past couple of years. But to me, the biggest thing is you need to respect the weather and what can happen, and understanding that you don't really exactly know what's going on. I mentioned this before. This is a big thing for me. Radar never actually sees all the way to the ground, because the radar is up off the ground and it never shoots down. So even if you're looking at radar scope, first of all, you're probably looking at a delayed radar picture, and second of all, you're not looking at exactly what's on the ground. So it's really important to understand that thunderstorms, especially supercells, are constantly evolving, and you only have access to one little snapshot that's sometimes 5 to 10 minutes delayed. So that's my biggest thing is just respecting. Make sure that if you don't have a lot of experience, maybe take a step back and don't focus just on what you're seeing on your cell phone.
Yeah, I think that's good advice. I definitely fall into that category. I don't have much experience chasing, and so I give myself as much distance as possible, but still being able to see the wall cloud or
And you know what? I mean, from my experience, a lot of times the most beautiful pictures that you can get, the beautiful sights you can get, and even some of the most educational things that you can see happen when you do take a step back. And so when you see the entire structure of the thunderstorm, a lot of times I'll go out. Actually, probably most of the times I go chasing anymore are on the low hype days where you know they're going to be storms, but they might not necessarily result in a major tornado day. I'll go out. I'm a sucker for a nice big shelf cloud as much as I am for a tornado.
Yeah.
So to me, seeing the processes that go into those are just as exciting as the processes that go into a tornado.
Yeah, I completely agree on that. So we're coming up on the 50-minute time here. We'll ask you the last question that we ask everyone who comes on the show. What kind of advice would you give to an up-and-coming research meteorologist? Maybe someone who's thinking about grad school or is in grad school right now. What kind of advice would you give them?
Okay, so the biggest key to success, I think, for grad school is to try to find a passion in what you're doing, or maybe even looking at that kind of the other way around. Whatever you have a passion in, try to do that. It's important to try to find an advisor in grad school that you enjoy working with, because otherwise that 2 to 3 years that you're working on your master's degree is going to feel like decades. I'm not saying that from experience. I was lucky enough to have an amazing advisor, both in undergrad with Paul Markowski at Penn State and grad school with Johannes Dahl at Texas Tech. But I've definitely seen situations where it wasn't the best situation. So that's the biggest thing, I think, going through grad school, is to just, don't get caught up on the semantics too much. Just look at the big picture, try to do something that really interests you, and at the same time, keep your options open too, because it's entirely possible that you'll find something that you're extremely passionate about, but you didn't even realize it at the time. So that's the thing for me, is keep your eyes open, try to follow what really, really interests you, and try to find someone that's really easy to work with.
Yeah, I love that point there. Finding the right advisor. That's the thing I think I tell everyone who's thinking about grad school is I find the advisor that you want to work with and make sure it's something you like to do, and you'll be set. Great advice, Matt, and thanks for joining us today.
Oh, thank you. Happy to be here.
And that'll do it for our show tonight. If you don't follow us on Twitter, you can follow us at the WX Junkies. We're also on Facebook, and you can listen to this podcast on SoundCloud, YouTube, iTunes, or any other podcast platform. And give us a rating or review if you want. We'd really appreciate it. We also have a website, theweatherjunkies.com. Join us there. Someone is very adamant about weatherjunkies.com. I think that's Tyler's mom. Thank you, Tyler's mom.
Oh, wow. I didn't know that.
Tyler, who's coming on next week?
We have Anne Jamonko, and it's a special date. It'll be on a Wednesday at 8 p.m., not the typical Thursday at 8 p.m.
Gotcha.
And we'll have him on on Wednesday, and we will send out a few tweets once we have more information about next week's show. But for this week, thank you to Matt for coming on the show, and we thank you for joining us on this Thursday, whether you're live or an on-demand listener. And we hope you will join us right back here next week.
Cow. I gotta go, Julia. We got cows.